Machine Dynamics Lecture Notes 15 Sample Problem. This example will be solved using the graphical method. It is a slider crank mechanism. A force of 100 newtons acts on this point of link 4. The value of the torque on link 2 is asked to keep the mechanism in equilibrium. While solving this problem, we will first determine the force system of the links in the same way as we did before. Link 2 is to forces plus 1 torque member. There is a force each at points B and C of link 3. Therefore, it is a two-force member. When we examine link 4, there is a force at point C. There is a horizontal force of 100 newtons acting at D, and there will be a force coming from the ground, plus a torque on it. Therefore, link 4 is 3 forces plus 1 torque member. You cannot say the torque value here is equal to 0, because the forces do not pass through a single point. There is a force acting at C and we don't know whether it passes through point D or not. That's why the value of torque cannot be said to be 0. Let us start to draw the free body diagram. Link 3 is a two-force member. We put the forces on link 2 and link 4, according to the action and reaction principle. When we separate the ground link from link 4, there will be a force, a torque. There will also be a force at point on link 2. This force is parallel in the opposite direction and equal in magnitude to FB. The free body diagram has been completed. Now, we can move on to force analysis. When we look at link 4 to perform the force analysis, we see that there are 3 forces, plus a torque on it. There is a force acting at point C, and as you can see here, 2 forces are acting at point D. If you consider that the resultant of these 2 forces will act from point D, there will be a resultant force here. There will be a force at C. Therefore, it will be 2 forces plus a torque member. So, how do we calculate the resultant of the force at point D? Of course, this means that the force of 100 newtons will have the component in the x direction and the force Fd will have the component in the y direction. The vectorial sum of these 2 forces has to be equal to the Fc force. At least we know the line of application of the Fc force. We know both the magnitude and direction of the 100 Newton meters force. We know the line of application of Fd. To find the resultant force, let's choose a center again and draw the 100 Newton meter force. When you place the Fd force on top of the 100 Newton meters force, when you place the line of application of the force Fd, we see that Fd must be downward to obtain Fc. The line of application of Fc will be in this direction. When we add Fd to the end of the force of 100 newtons, we do not know whether it can be upwards or downwards, but we know that the direction of Fc must be along the direction of the BC line. Then this vector plus that vector must be equal to the BC line orientation, as we see from here. For Fc orientation to be equal to the BC line orientation, the direction of the force Fd must be downwards, and this vector plus that vector should be equal to this resultant vector. In other words, the resultant force that will act at D, the direction of the combination force that will affect it from D, must be in this direction. And if the force acting from D is in this direction, the force Fc must also be in this direction. From here, the magnitude of the force Fd is 116 Newton meters. If it is 116 Newton meters, then force Fc is also 116 Newton meters. Force Fb will be 116 newtons and force Fa will be 116 newtons. The perpendicular distance between these two, as seen from here, the angle made by force Fa with AB or the angle made by force Fb with AB. Since it is 90 degrees, it means equal to the AB link length. The perpendicular distance between them. We can easily find the value of the torque from here. If you take a moment about point A, the torque 2 will be equal to the distance AB times the force Fc. This is 2.9 Newton meters. Which way is the rotational motion? The direction we have chosen here is correct, so it's clockwise. So our answer is torque. 2.9 Newton meters on link 2 and clockwise. Thank you for watching the video.